The Allied landing in Normandy is often summarized as an infantry assault supported by a few iconic tanks, yet the operation relied on a vehicle ecosystem of unusual scale and diversity. In June 1944, the Allies deploy more distinct vehicle types in a single amphibious operation than in any previous military landing. Many of these systems were purpose-built for conditions that existed only on the beaches of northern France. This video presents a complete catalog of every Allied vehicle deployed on D-Day, examining their roles, origins, and design intent as an integrated operational system rather than isolated machines. This catalog covers Allied vehicles deployed on the 6th of June 1940 for during Operation Overlord, with primary focus on Normandy coastal sectors and immediate inland objectives. The time frame centers on D-Day itself and the initial assault phase, rather than the prolonged breakout that followed. Geographic emphasis includes the British, Canadian, and American landing zones, with supporting naval and airborne elements or vehicles directly contributed to the landings. Organization follows operational function, grouping vehicles by battlefield role rather than nationality. Excluded are individual weapons, purely naval vessels, and post-landing logistical assets introduced after June 1944. The Allied vehicle inventory on D-Day emerged from a practical requirement to move men, firepower, and supplies from ship to shore under direct fire, then continue inland across terrain altered by flooding, obstacles, and demolitions. The following groups progress from beach access systems to armored support and specialized engineering vehicles, reflecting how mobility problems were addressed in sequence. Amphibious and shore-crossing vehicles. These vehicles existed to solve the transition problem between sea and land, a phase where conventional wheeled and tracked systems failed. To Quantitative states 1942 per amphibious logistics carrier. It was designed to transport troops and supplies directly from ships to inland positions without unloading at a port. The vehicle combined a standard truck drivetrain with a boat-shaped hull and propeller. Its most distinctive feature was central tire inflation, allowing pressure changes while moving. On D-Day, it reduced congestion on beaches by bypassing fixed unloading points, unlike standard trucks that required cleared exits. LVT to water. Buffalo United States 1942 per amphibious track transport. It was designed to carry infantry and cargo across water and soft sand, where wheeled vehicles failed. Originally developed for Pacific operations, it used wide tracks to distribute weight. In Normandy, saw limited but critical use in rough surf conditions. Its tracked mobility distinguished it from wheeled amphibians in high resistance beach zones, beach clearance, and engineering vehicles. Once troops reached shore, obstacles and terrain modification became the primary limiting factor. Armored bulldozer Caterpillar D7 United States 1943 combat engineering vehicle. It was designed to clear beach obstacles, fill craters, and create vehicle exits under fire. The bulldozer blade allowed rapid terrain reshaping, while improvised armor protected the operator. Its effectiveness lay in speed rather than protection, enabling follow-on vehicles to move inland faster than planned schedules assumed. Churchill Avery United Kingdom 1943 per assault engineering tank. It was designed to destroy fortifications and clear obstacles using direct fire demolition. The vehicle mounted a 290mm spigot mortar known as the Petard. Its most memorable feature was the short range and massive blast effect of its rounds compared to standard tanks. It sacrificed anti-armor capability for immediate obstacle reduction, mine clearing, and obstacle reduction vehicles. German beach defenses relied heavily on mines and physical barriers, requiring dedicated countermeasures. Sherman Crab United Kingdom 1943 per mine-clearing tank. It was designed to detonate mines safely ahead of advancing troops, or rotating flail drum-triggered mines by impact. The system produced a distinctive dust plume, making the vehicle highly visible. Its contribution was not firepower but route creation, allowing conventional armor to follow without delay. Churchill United Kingdom 1940 for per mobile armored bridge. It was designed to allow vehicles to cross obstacles without deploying separate bridging units. The tank turret was removed and replaced with a ramped superstructure. Vehicles drove directly over it. This eliminated time-consuming bridge assembly during the assault phase. A capability standard tanks lacked. Direct fire support tanks. Fire support during the initial landings required armored vehicles capable of engaging bunkers rather than enemy armor. Sherman to United States and United Kingdom 1940 per amphibious assault tank. It was designed to swim ashore ahead of infantry, using a collapsible flotation screen. Propellers driven from the main engine provided movement. In calm conditions it reached the beach. Under its own power, in rough seas many were lost. When successful, it delivered immediate armored fire support, unavailable from infantry weapons alone. Centaur for United Kingdom, 1943. Close support tank. It was designed to provide high explosive fire against fortifications, armed with a 95mm howitzer. It prioritized blast effect over penetration. Many were operated by Royal Marines, compared to standard cruiser tanks. It emphasized fixed target suppression rather than maneuver combat. Self-propelled artillery and indirect fire vehicles. Artillery mobility was essential to maintain pressure once beachheads were secured. And 7 United States, 1942 per self-propelled artillery. It was designed to deliver mobile indirect fire while keeping pace with armored units. The vehicle mounted a 105mm howitzer on a modified tank chassis. Its open fighting compartment allowed rapid rate of fire. Unlike towed artillery, it could displace quickly to avoid counter-battery fire. Sextonkinata, 1943 per self-propelled artillery. It was designed to provide Commonwealth forces with mobile artillery using familiar ammunition. Based on a tank chassis and armed with a 25-pounder gun. It unified logistics with existing British artillery doctrine. Its value lay in compatibility rather than innovation. Infantry mobility and light utility vehicles. Sustaining momentum inland required flexible transport for command, supply, and rapid repositioning. Willie Zambigi United States, 1941. Light utility vehicle. It was designed to serve as a general-purpose transport for personnel, weapons, and communications. Its simplicity and reliability defined its success. On D-Day it functioned as liaison, reconnaissance, and casualty transport, compared to larger trucks. It offered unmatched flexibility in confined terrain. GMCCCKW 2.5-ton truck United States, 1941. Medium logistics truck. It was designed to move large volumes of supplies from beach depots to forward units. The vehicle's 6-wheel drive improved off-road performance. Its contribution was logistical continuity rather than combat action, enabling sustained operations beyond the shoreline. As the initial assault phase stabilized, Allied planners faced a shift from immediate access problems to sustained inland maneuver, setting the stage for a change in vehicle priorities and design emphasis. By the middle of the landing day, the primary challenge was no longer reaching the shore, but sustaining movement beyond it. Vehicles initially designed to overcome surf, sand, and obstacles gave way to systems optimized for endurance, reliability, and coordination across mixed terrain. This transition reflected a broader doctrinal shift from assault engineering toward combined arms mobility. Armored vehicles began operating in deeper coordination with artillery, logistics, and command elements. The effectiveness of the landings increasingly depended on how rapidly temporary, purpose-built systems could be replaced by standardized platforms capable of prolonged operations. Inland, as the beachhead expanded, Allied forces introduced vehicles that were less visible in popular accounts, but critical to consolidating control and enabling sustained combat operations. Many of these systems represented transitional designs, bridging the gap between specialized assault vehicles and post-landing field armies. Armored recovery, repair, and adaptation vehicles. Maintaining momentum required keeping damaged vehicles operational under combat conditions. M30 to tank recovery vehicle United States 1943 per armored recovery vehicle. It was designed to recover disabled tanks under fire and return them to service, based on the Sherman chassis. It incorporated a winch, crane, and towing equipment. Its presence reduced vehicle losses or repair rather than replacement, a capability absent in earlier campaigns where damaged armor was often abandoned. Churchill Armored Recovery Vehicle United Kingdom 1940 per armored recovery vehicle. It was designed to support heavy assault tanks operating close to fortified areas. The vehicle retained thick armor, or replacing armament with recovery gear, its importance lay in preserving scarce specialized vehicles such as AVers, which could not be easily substituted, command, control, and communications vehicles. Effective coordination across congested beachheads required mobile command platforms. M3A1 half-track command variant, United States, 1942. Armored command and control vehicle. It was designed to transport headquarters staff and radio equipment close to frontline units. The open rear compartment allowed multiple radios to operate simultaneously, compared to Jeeps. It offered greater protection and space, enabling sustained command presence during the advance inland. Wireless truck, 15. United Kingdom, 1943. Signals vehicle. It was designed to provide mobile communications between landing forces and follow-on units, fitted with multiple radio sets. It prioritized connectivity over cargo capacity. Its role emphasized information flow as a combat multiplier rather than physical firepower. Specialized late assault engineering vehicles. Some vehicles addressed problems discovered only after the initial landings began. Churchill Crocodile, United Kingdom, 1940 for per flamethrower tank. It was designed to neutralize fortified positions resistant to conventional fire. The system used a trailer-mounted fuel supply feeding a hull-mounted projector. Its psychological and tactical effect exceeded its physical destruction, reducing resistance in fortified zones where infantry advances stalled. Emperor Sherman Dozer, United States, 1940 for per armor engineering tank. It was designed to combine fire support with earth-moving capability. A front-mounted blade allowed it to clear debris while retaining its main gun. This dual-role approach reflected lessons learned from earlier beach congestion and delayed exits. Vehicles signaling post-war design trajectories. Some D-Day vehicles influenced armored doctrine beyond 1945. Emperor A3 to Jumbo Sherman, United States, 1944. Assault tank. It was designed to survive frontal engagement with fortified defenses through increased armor thickness. The vehicle sacrificed speed for protection. Its emphasis on survivability foreshadowed later heavy armor concepts focused on crew protection rather than mobility alone. Universal Carrier, United Kingdom, 1938 per light track carrier. It was designed to transport infantry support weapons and supplies under armor, though lightly protected. It offered terrain access beyond wheeled vehicles. Its widespread use demonstrated the enduring value of simple, adaptable track platforms. These systems illustrate how the final stages of the assault phase blended improvisation with emerging standardization, pointing toward the structure of allied forces in the final year of the war. The vehicles deployed on D-Day reflect a pattern of design driven less by technological ambition than by immediate operational necessity. Each system existed to solve a narrowly defined problem, from crossing surf and sand to clearing obstacles and sustaining inland movement. Taken together, this catalog illustrates how modern warfare depends on integration rather than singular platforms. The Normandy landings demonstrate that decisive outcomes often rest on unglamorous, purpose-built vehicles operating in coordination. These design principles continued to shape post-war armor and logistical doctrine. For further reference-based military history analyses, neutral documentation of this kind supports long-term understanding.